Hello, let's try to solve another question from exponential equation. Here we have to show that when we solve the expression on the left hand side, this four expression on solving should give p by q to the power p plus q. So when we let's try to simplify these four expressions that which is on the left hand side of equation. So but first let me write down the expression once again. So I've copied the expression which is on the left hand side. And now when we look at this expression, the first expression, clearly we can see that it's in the form uh, p squared and minus 1 by q squared can be written as 1 by q whole squared. It's the same thing. When we solve 1 divided by q whole squared, we get 1 by q squared. So we can say that this expression is in the form a squared minus b squared. And when we try to expand this formula a squared minus b squared, we know the formula for a squared minus b squared is a plus b and a minus b. So our first job here is to expand this expression right here, p squared minus 1 divided by q squared in form of a plus b, a minus b. We can also say that this expression right here is also in form a square minus b square, since 1 divided by p squared can be written as 1 divided by p whole squared. So on solving we get the same 1 squared by p squared, which is 1 divided by p squared. So we can say that this expression is also in form a square minus b squared, so it can be expanded in form of a plus b, a minus b, which is the formula for a squared minus b squared. Also inside this expression we've got two more expression. We've got the first expression p separated by negative sign from the second expression 1 divided by q, and it has got the whole power of q minus p. We can also take this expression which is inside the bracket as the single term, say x. So we can say that this expression is in the form x to the power q minus p. So the formula for x to the power q minus p, when we expand this, we get x to the power q times x to the power minus p, such that on adding the power, since the bases are same, we get the same, which is x to the power q minus p, which is same as the question. So we can expand this expression right here in form of p minus 1 by q to the power p times p minus 1 by q to the power minus p. So I hope you understood the concept involved over here. So for this expression I can expand it and write it this way. And when we look at this expression right here, we can take it as a single expression x, which has got the power p minus q, and we can do the same, which is to distribute the power to making two bases. So for x to the power p minus q, we can write x to the power p times x to the power minus q. Since we know that x to the power a plus b means x to the power a times x to the power b, the same concept involved for the negative power, which is x to the power a minus b means x to the power a times x to the power minus b. So this expression right here can be expanded in similar form. So let's try to solve for this first expression. I've already told you that we can write it in form of a plus b, a minus b. So for a I'll write p, and for b I should write 1 by q. So a plus b and a minus b, and it has got the whole power of p times, and for this expression right here we can break it as 1 by p minus 1 by q to the power q times p minus 1 by q to the power minus p. I've already told you which formula to apply over here. We can do the same for this denominator, expand it in form a plus b, a minus b. So on doing, we get a as q and b as 1 by p. times it is a plus b, and this is a minus b to the whole power. Since it has got the whole power of q, I write q over here, and I'll also expand this term just by giving the power to the same term p plus 1 by p. I'll just distribute this to power q plus 1 by p to the power minus q. Sorry, here is plus. I hope you got the concept I've applied right now for this part. Now, one more thing I want you to remember is here inside this curly braces, we've got two expressions. Say this is our first expression x, and this is our second expression y, and these two expressions, they've got the common power, which is p over here. So we can write this in the form of x to the power p times y to the power p. I've just distributed the power, common power p, for these both expression, and I can write it this way. It is yet another rule for indices, another rule of indices. So what I can write here is p plus 1 by q to the power p. I'll give this p for first expression, and also I'll give this p for the second expression. So I'll give this p to this guy right here, and for other term I'll write as it is. So this becomes my numerator part. Now for denominator part, I'll once again distribute the power q for these two expressions. So I'm doing it. So I've done the denominator part according to the rule I've applied for the numerator. Now let me get rid of this portion. We are almost at the end. Now I want you to know that this term p minus 1 by q, it has got the power p, and we've got another the same term p minus 1 by q. It's the same term, and it has got the power of negative p, and they've been multiplied. So if we've got x and it has got the power p, and we've got another expression which is also x but it has got negative power, which is negative p. So when we multiply these two terms, what we get is x to the power p. These two power get added, but here is negative sign, so we got x to the power p minus p is 0, so we get x to the power 0 is 1. So what we can say here is these two expression right here, they multiply to give 1, since they are the same expression having the negative power, or the power with different opposite sign. Similarly, when we look at this expression q plus 1 by p, which has got the power p q, we can also see that there is the same expression q plus 1 by p, and it has got the negative sign, negative power sign, which is negative q. So this two term also multiplies to give 1, since the power add up to give 0. So we can get rid of these 4 terms, and the remaining term will be this 4 term. So I've erased that portion which multiplies to give 1, and these are the remaining 4 terms. Now let us try to take LCM for this part, which is p plus 1 by q. The LCM will be q, and in place of p we get pq plus 1, and it has got the power of p. I hope you know how to take LCM, and similarly I'll take LCM for this second term, which is q. In numerator I get pq minus 1 and power q. I'll do the same for denominator. So this is what I got for my denominator when I take LCM. Also, one more thing, a concept involved over here is, let us take a look at this fraction. Say the numerator is a and the denominator is b. I've just supposed any random variable, and it has got the power p. So according to the rule of indices, we can just distribute the power to both the numerator and denominator. So I'm doing so we get a to the power p divided by b to the power p. This is yet another concept of indices. I'll apply the same concept for every. So after applying the same concept for this remaining for these 4 expression, what we get is our first expression becomes pq plus 1 to the power p, I've distributed the power to both numerator and denominator. So denominator is q to the power p, and for second expression I'll do the same. On distributing the power, I got this term over here. Here pq plus 1 to the power p on numerator and pq plus 1 to the power p on denominator gets cancelled. Similarly, pq minus 1 to the power q and pq minus 1 to the power q on numerator and denominator gets cancelled. And what remains over here is 1, so I write 1. And here q to the power p times q to the power q means they have same base but power is different, so I'll just add up the power. So this gives q to the power p plus q whole upon so these two terms are cancelled, so here's what remains is 1. And here we've got the same base, which is p, and they've got different power, q plus p, so we can just add the power, p to the power. If same base have power, same or different power, we can simply add the power. Finally, we can do reciprocal. I'll write this expression as it is, p plus q, and this denominator, it becomes the numerator, so it becomes, this is the symbol concept for reciprocal, and this one becomes the denominator right here. Here on numerator and denominator, we've got different bases, but they have the same power. So if we have two different bases, say x and y, and they've got the same power, say a, we can combinedly write it as x divided by y and give it the same power, which is a, since they've got the same power here. We can do the same for this expression. So we've got different power, which is p and q, but what we know is that they've got the although they've got the different base, they've got same power, which is p plus q, so I'll represent it as whole power for p plus q, such that on distributing, p also get the power p plus q, and also q gets the power p plus q, which is equivalent to this expression. So yes, this is what we have to solve according to our question, and we're done. I hope you got the concept, and yes, thanks for watching, and please do subscribe for similar updates. Thank you.